Let's continue this this discussion. This second example. In the third example, we have a cosine 17 pi over 6. Cosine 17 pi over 6. Let's try to break it, okay? So 17 pi over 6. 12 pi over 6 is 2 pi. Okay, so this is a 12 pi plus 5 pi is 17 pi. So 12 pi over 6 is 2 pi plus 5 pi over 6. Okay, so let's check. This is a 2 pi and 5 pi over 6. If you move to the straight angle, it will be another pi. Another pi, you still miss pi over 6. So this is a reference angle. This is a 17 pi over 6, and the corresponding reference angle is pi over 6. Okay, so the cosine 17 pi over 6 is cosine pi over 6. It's in the second quadrant. In the second quadrant, cosine is negative, so you must put a negative sign. And pi over 6 is 30 degrees, so it's negative square root of 3 over 2. Cosine pi over 6 is a square root of 3 over 2. Okay, last one. Tangent of negative pi over 3. Tangent of negative pi over 3. The reference angle is just pi over 3. You ignore the sign. You have negative sign because of the orientation is clockwise, but when you talk about the reference angle, you just consider the acute angle. It's always positive. So the tangent negative pi over 3 is equal to tangent pi over 3. So this is a reference angle. And secondly, you have to determine the sign. It's a quadrant 4. In quadrant 4, tangent is negative, so it's negative tangent pi over 3. Tangent pi over 3 is square root of 3. So it's negative square root of 3. See? So we can still use the definition of the definition of trigonometric functions for acute angles to determine the value of trigonometric functions for any angle, but you have to adjust the sign. Sometimes it's positive, sometimes it's negative. Which one is positive? Which one is negative? It depends on the table we have, ASTC, ASTAC. In the first quadrant, all trig values positive. Second quadrant, sine positive. Third quadrant, tangent positive. Fourth quadrant, cosine positive. Okay, so ASTAC. And it's a very useful trick. Okay, very cool. Now let's make the problem more comprehensive. We're going to find the exact value. Okay, this is the part 6. Find the exact values of trigonometric functions of an angle given information about the function. Okay, so there are several given information and we can determine the values. Let's see the example. This is a very good problem, very good type of a problem. So given that cosine theta is equal to negative 2 over 3. And pi over 2 is between theta and pi. Theta is between pi over 2 and pi. Find the exact value of each of the remaining trigonometric functions. Okay, so we only have one value, exact value, but we have the position. It's in the It's in the second quadrant. Okay, between pi over 2 and pi, it's in the second quadrant. You have a exact value and the position. We can determine other 5 trig values. How do we do that? Let's do it in 2 different ways. The first way, cosine. And angle in the second quadrant. In second quadrant, we know sine is positive, so we get at least the sine theta is positive. Okay, cosine is negative 2 over 3, sine theta is positive. Theta is in the second quadrant. And what is the relation between sine and cosine? We get cosine theta squared plus sine theta squared is equal to 1. This is a fundamental identity. You must memorize it, okay? And from here, we get sine theta squared is equal to 1 minus cosine theta squared. And then we take square root. Here, we'll use that sine theta is positive. So when you take square root, you only choose the principal square root, the positive square root. So this place, you use this information. You use the information of the place of a terminal site. Okay, cosine theta is negative 2 over 3. So cosine theta squared is 4 over 9. You square it, the negative sign disappears. You get 4 over 9. 1 minus 4 over 9 is square root of 5 over 9. So it's a square root of 5 over 3. So this is sine. Based on our experience, if you know cosine, if you know sine, you know everything. Okay, so sine this, then what is a tangent? Tangent is sine theta over cosine theta. It's a root 5 over 3 over negative 2 over 3. You multiply top and bottom by 3, you cancel the denominator, so you get tangent theta is negative root 5 over 2. Okay, you have sine, you have tangent, you have cosine, then the cotangent. You flip the number, 2 over root 5. You can leave this as answer. You don't have to simplify it. Again, you can leave this as an answer. Don't simplify. And the sine, you flip it. Cosecant theta is 3 over root 5. Secant theta is negative 3 over 2. It's a reciprocal of a cosine. Okay, so you see here. You have other, here also. 1, 2, 3, 4, 5. You have other 5 remaining trigonometric functions. Okay, so this is done by the detailed algebraic computation. We start from the fundamental identity, and we use the square root, positive square root, based on the positions, and we get everything. Okay, so this is method 1. Method 2. Method 2 is the following. We just use the acute angle. You see, cosine is 2 over 3. What is a cosine? Cosine is adjacent over hypotenuse. In the right triangle, cosine is defined by the adjacent over hypotenuse. So we just assume the adjacent is 2, hypotenuse is 3. You ignore the sine first. So what is the opposite side? Opposite side, by the Pythagorean theorem, b squared plus a squared is equal to 3 squared. So b squared is 9 minus 4 is 5. So b is square root of 5. So by the Pythagorean theorem, you get the square root of 5. And then let's form the trigonometric values. Sine theta. Sine theta is going to be opposite over hypotenuse. Opposite over hypotenuse. What is the sine? Here you use the condition again. Theta is between pi over 2 and pi. It's in the second quadrant. Sine is positive, so you put a positive sign. Positive sign is not necessary to be written, so you just get the square root of 5 over 3. So you see, the same thing. Once you get this square root of 5 over 3, you just use those relations. You will get the tangent. Let's write it again. Tangent the sine over cosine. So it's this value over negative 2 over 3. It's negative square root of 5 over 2. And then you get the cotangent, negative 2 over square root of 5. And secant is negative 3 over 2. You flip cosine, you get the secant. You flip cosine, you get the secant. And the cosecant, you flip sine, you get the cosecant. 1, 2, 3, 4. And plus 5. Okay? The same thing. The same value, but you have different approach. So I will recommend you to use the second method. The second method is inspired by this reference angle. This theta in this acute angle, in this right triangle, this theta, this acute angle is the reference angle. Okay, so you can either use this one or you use the first method. You ignore the reference angle, whatever. You just use a identity. And remember, there are 3 equivalent identities. You will have sine theta squared plus cosine theta squared is equal to 1, or you will have 1 plus cotangent theta squared is equal to cosecant theta squared, or you will have tangent theta squared plus 1 is equal to secant theta squared. So if they give you cosine, you can find the sine based on this one. If they give you the cotangent, you can use the second identity to find the cosecant. If they give you the tangent, you can use this identity to find the secant. So either way, you have one, you can find the other one. Once you have 2 trig values, you can almost determine the other remaining trig values. Okay, so let's do one more example. For example, if tangent theta is negative 4 and the sine theta is less than 0, find the other. See, you only have this one. Find the other 5 remaining trigonometric values. Okay, so we only have this condition. Let me write. Find the exact value of each of the remaining trigonometric functions of theta. Very good. Let's check how do we start. Because in this problem, the quadrant is not directly given. It's not like the previous one. Previous one, they tells us the theta is between the pi over 2 and the pi. And here they don't give us. Because tangent is negative, sine is negative. tangent theta is negative 4, negative. Sine theta is negative. There's only one quadrant, so that these two functions are both negative, the quadrant 4, because in quadrant 4, all as tech, we mean the quadrant 4 only cosine positive, the other two negative. So the theta is in quadrant 4. Theta is in quadrant 4. This is a very, very important position. Okay, very good. Once we get quadrant 4, let's see how do we do that. Tangent is negative 4. Negative 4, we consider it as a negative 4 over 1. We have numerator and the denominator. And then we get the reference angle. Reference angle. Tangent is opposite over adjacent. So the opposite is 4, adjacent is 1. It's an acute angle, so it's always a positive number. Opposite is 4, adjacent is 1. Then by the Pythagorean theorem, we can compute the hypotenuse is 17. C squared is 17, so C is the square root of 17. C is the square root of 17. And you have adjacent, opposite, hypotenuse. Then what is the sine theta? Sine theta is opposite over hypotenuse. But the sine theta is negative, you put a negative sign. Okay? And the cosine theta is adjacent over hypotenuse. Adjacent over hypotenuse. But it's in the quadrant 4. Cosine is positive, so you just put a positive. Put a positive, you can ignore it. Just put 1 over square root of 17. Okay, so you have 1, you have 2, you have tangent, and then you flip them. So the sine, you flip it, you get a reciprocal. Cosecant is negative square root of 17 over 4. Cosine, you flip it, you get a secant. Secant theta is square root of 17. And the cotangent theta is reciprocal of negative 4 is negative 1 over 4. So see, you have the exact value of each of remaining trig values. Okay, so this is a method 1. We use the reference angle. Let's see if we use the algebra. Okay, so still we need to determine which quadrant the theta is. So method 2. Tangent theta negative, sine theta negative, so theta is in quadrant 4. Okay, this is always required, necessary, important. Okay, so we know that 1 plus tangent theta squared is equal to secant theta squared. Okay, so the quadrant 4, cosine is positive. Secant is also positive. Secant is the reciprocal of cosine. A positive number, flip it, is still positive. So you take square root. You only choose a positive square root. So secant theta is square root of 1 plus tangent. Tangent is negative 4 squared. So square root of 17. 1 plus 16 is the square root of 17. So you see here, this one. Secant theta is square root of 17. Then you flip secant, you get a cosine theta, 1 over square root of 17. 1 over square root of 17. This is a cosine theta. And you know what? You know tangent theta is sine over cosine. So from this identity, we know that sine theta is tangent theta times cosine theta. Right? You just move this denominator to the left side. You write the product. So sine theta is tangent negative 4 times cosine 1 over square root of 17. So it's negative 4 over square root of 17. So let's see what we got. We got a 1, we got a 2, we got a 3. At least so far they're all correct. And you got a tangent, cotangent theta is negative 1 over 4. So 4. And sine, you flip sine, you get a cosecant. It's negative square 17/4. You get the last, the fifth. So either way, there's no difference about the computations. You will get the identical answers, either by the first method, by the reference angle, or by the algebra. I mean, when you do exercise, I recommend you to try both methods in order to handle both of them. But in the exam, you can choose either of them. You don't have to present both methods for one problem in the exam. Okay, so we finished the section 7.4, trigonometric functions of any angles. So far, you can compute the trigonometric functions for arbitrary angle once you can find a point from the terminal side. Okay, so do the exercise, send me email if you have questions. Okay, we finished this video.